the space-time calculation with respect to all the industrial reactors, right? The term space-time is correct for all the industrial reactors. Okay, the the term volume is correct for all the industrial reactor, right? Whether it may be batch reactor or whether it may be continuously flow reactor, right? Both the term space-time and volumes are correct for the individual industrial reactors. Okay, now here the term volumetric flow rate. Now here the term volumetric flow rate. This is exactly where the students make mistakes, right? The volumetric flow rate is the where the students make easily mistakes, right? So let's say volumetric flow rate, which means what? The by using this concept, we have solved the volume of the batch reactor, right? So the concept is correct, but the calculation is partially wrong, right? The calculation of volume of batch reactors is not correct here. Okay, this is exactly where the students make the mistakes, right? So why? We'll understand that. Let's say volumetric, the space time is okay, volume is okay, right? But volumetric flow rate, which means volumetric flow rate we have has volumetric flow rate of 15 cubic decimeter per hour, which means volumetric flow rate, which means the volume of the fluid which is entering into the reactor in the reaction environment. The reaction will take place and will get converted into the new product, and that product will exit through the outlet stream, right? I hope you have understood. Okay, which means see the units, understand the units. The volumetric flow rate is 15 cubic decimeter per hour, which means 15 liters of volume of fluid will enter the reactor via inlet stream. In the reaction environment, the reaction will take place, and same 15 liters of volume of fluid will exit through the outlet stream of the reactors, right? Okay, with respect to each and individual hours, which means the volumetric flow rate indicates the continuous flow, right? Which means for the first hour 15 liters volume of the fluid will enter into the reactor and the reaction will take place, and 15 liters volume will exit through the outlet stream of the reactor. Again in the second hour, the 15 liter volume of the fresh feed will enter into the reactor via inlet stream. In the reaction environment, the reaction will take place and will get converted into the new product, and that fluid will exit through the outlet stream of the reactors in the second hour. Similarly, in the third hour, 15 liters volume of the feed will enter into the reactor, reaction will take place, and the fluid stream will exit through the outlet stream of the reactors, right? So the volumetric flow rate indicates the continuous flow rate